Hey everyone, Dasha here. Let's dive right into the incredible, mind-blowing world of technology. Welcome to our brand new segment, Quantum Digest, where we'll break down the hottest quantum news. This is one of the most exciting fields out there right now. We're kicking things off with a quick look back at this year's biggest quantum highlights. So hit that subscribe button if you're into how cutting-edge technology is shaping our world and you want to be ready for a future that could completely change everything we know. While talk of the quantum threat used to be mostly among specialists like us, this year everyone started discussing it. From the creators of the biggest blockchains to Forbes analysts, everyone began asking one question: what happens when a quantum computer can crack our digital security? And you know what? We at Cellframe look at this with a unique feeling. On one hand, yes, we've been preparing for this from day one, building post-quantum encryption into this very foundation of our architecture. But on the other, it's impossible not to be in awe of the tremendous scientific leap that happened this past year. And we're incredibly happy that the entire community has finally realized the scale of the problem and started taking action. Let's walk through the key events of this pivotal year together. Part 1. The wake-up call that got everyone responding. A strong public impulse came from Vitalik Buterin's statement at DevConnect. He voiced what many specialists had been whispering about: the community might have only about 3 years left to prepare. This wasn't the discovery of a new threat, but its clear and public acknowledgement at the highest level, instantly elevating the topic as a priority for the entire crypto community. This moment became a catalyst. Discussions that were once confined to narrow technical circles turned into concrete and urgent work. The most active debates centered around two giants, Ethereum and Bitcoin, and their approaches turned out to be completely different, reflecting the philosophy of each network. In Ethereum, the focus shifted to the second layer, L2, and rollups. The main idea is to start implementing new cryptography, where it's easier and doesn't require an immediate consensus change to the entire network. For example, the ZXNox project, supported by the Ethereum Foundation, showed how to significantly reduce the cost of post-quantum operations, making them more applicable in a smart contract environment. This is a pragmatic, cautious approach that allows for building the first protected applications while the main network prepares for more extensive charges. But it's important to understand that PQ rollups alone are not a panacea. They can only be a temporary solution, and L1 rework will still be necessary. And the Ethereum team has yet to address this issue. In Bitcoin, the conversation, long held in narrow technical circles, reached a new level of urgency in 2025. It became finally clear that the threat is not abstract. The key vulnerability at the center of all discussions is digital signatures, ESDSA, the very foundation of the network's security. Publications like Forbes merely highlighted this critical fact, drawing broad attention to a problem already being actively and deeply addressed by developers. In response, the community is not just talking, it's structuring the work. Technical working groups are being formed to develop specific proposals. Different scenarios are being considered, from temporary measures to fundamental changes. Talks are about a potential shift to hybrid signatures, where a transaction is signed with both old and new cryptography, or a complete replacement of the digital signature algorithm with a post-quantum one. The key words here are security, decentralization, and backward compatibility. Any decision must be accepted by the entire community through a careful and likely lengthy consensus process. In parallel, other platforms, Algorand, Polkadot, Cardano, are advancing along their own paths, integrating post-quantum elements at the base layer or offering them as a service. For us at Cellframe, where post-quantum protection is the foundation of the entire architecture, this trend is extremely important. We've always believed that post-quantum security is a basic standard, not an option. And it's great to see this philosophy finally becoming mainstream, even if through different interim steps. When the entire industry moves in one direction towards greater security, all users win. Part 2. The standards race, when cryptography becomes geopolitics. But what will actually replace current cryptography? Here, 2022 showed that this is not just a technical question, but already a matter of technological sovereignty. The American Institute NIST, which has been selecting new algorithms for years, began its final standardization process this year. Essentially, they are saying, here is a set of mathematical tools we believe will withstand a quantum attack. And immediately, China announces its own international competition to create post-quantum cryptographic standards, stating directly, "We need an alternative, we want our own standards." This is an unprecedented step that turns cryptography into a field of global competition. Why? Because whoever's standards become global will set the rules for protected digital communication in the future. And on the practical front, we see the birth of hybrid solutions. Google, for example, is testing a scheme in Chrome where both old and new cryptography are used simultaneously. It's like flying a plane with two independent engines. If one fails, the other will get you there. This approach allows the transaction to begin right now, without waiting for the end of all cryptographic wars. For us building secure systems, this stage is incredibly important. It shows that the world is taking the problem seriously, but also reminds us we should only trust algorithms that have undergone open, international, and comprehensive analysis. After all, the security of everyone's data is at stake. Part 3. Scientific Wonders of 2025. Marveling at Progress. Now, let's step away from the threats and standards and simply admire science. Because in 2025, physicists and engineers achieved what used to take years. And it's incredibly fascinating to watch, even when you're working on protection against these very technologies. For example, the creation of time crystals. It sounds like magic, but it's pure physics. If an ordinary crystal, like a diamond, has a repeating structure in space, a time crystal repeats its state in time, like perfectly precise quantum clocks ticking without an external power source. In 2025, scientists not only created them in the lab, but also showed how they can work in systems of many particles. How is this related to quantum computing? It's a breakthrough for quantum simulation. Imagine you need to model a new superconducting material for qubits or study extremely complex magnetic behavior. A classical computer can't handle it. But a time crystal is exactly such a ready-made, perfectly synchronized quantum system that can be used as a live simulator of this phenomena. It's not a tool for running Shor's algorithm, but a powerful research platform that will accelerate the creation of the very materials for future quantum computers. Then there is the quantum refrigerator that runs on ambient heat and cools qubits to near absolute zero. Engineering brilliance worthy of admiration. Or the 10-second record for quantum memory based on the familiar silicon. A full 10 seconds of stable operation. For the quantum world, that's an eternity and a huge step towards practical devices. Our favorite story is from Caltech. They figured out how to store quantum information not in electrons, but in mechanical vibrations of a tiny tuning fork. It's so elegant and clever. This way, information lives 30 times longer. Such solutions show that human ingenuity knows no bounds and is truly inspiring. Part 4. The Race of Giants, Year Summary, and the Nobel Finale. Corporations aren't standing still either. Their race in 2025 entered a new phase. Not who has more qubits, but whose are smarter and more stable. IBM is working on a quantum supercomputer architecture. Microsoft is investing billions in topological qubits, a concept where information is protected by the very geometry of the system, like a knot that cannot be untied. Google reports on computations that already cannot be accurately reproduced on classical machines. And this is already a global race of nations. China, India, the USA, the European Union, all are investing tens of billions because they understand whoever leads in the quantum era will set the tone for the future. For us, as a project focused on security, this race is another confirmation that we were right. Development is moving at a breakneck pace, and being prepared in advance is not paranoia, it's responsibility. And do you know what moment became the brightest symbol of this turning point year? The 2025 Nobel Prize in Physics. It was awarded for fundamental discoveries from the 1980s in this field of macroscopic quantum effects. The very work that directly laid the foundation for creating modern superconducting qubits, the heart of processors from IBM and Google. This is a powerful signal. It reminds us that today's technological revolution, all this talk of threats and protection, grew out of the deep, pure science of the last century. The Nobel Committee seems to put a final point, confirming, yes, the quantum era is not science fiction, it is our reality, and its foundation was laid long ago. Finale and outro. So what's the bottom line? 2025 was the year the threat was voiced aloud. the industry started acting and science received its highest recognition. A year that erased the line between yesterday's fundamental discovery and tomorrow's technological necessity. We at Cellframe look to this future with calm confidence. We didn't wait for an alarm signal or novel confirmation to start building a secure network. Our philosophy is to be ready for QDay today. And we are proud to be able to offer a ready-made solution based on proven principles, while others are just beginning their journey. But most importantly, we are glad this journey has begun, because when the entire industry moves towards greater security, everyone wins. What do you think? Are you more amazed by scientific breakthroughs like the Nobel-winning ones, or more concerned about the new threats? Do you trust ready-made post-quantum solutions, or are you waiting for the big players to update everything? Be sure to write in the comments. Your opinion is important to us. Like this video if you want more in-depth analysis like this, and subscribe to this channel. Here, we don't just follow the future, we build it. See you next time.